Okay, my article is titled Cerebrospinal Fluid Derived from Progressive Multiple Sclerosis Patients Promotes Neuronal and Oligodendroglial Differentiation of Human Neuronal Precursor Cell in Vitro. So that's like really confusing. So in other terms, you could just say, how can we use patient spinal fluid to help repair their damaged nerve cells and create new ones? So first, you kind of have to know what MS is. So MS stands for multiple sclerosis. It's the destruction of the myelin sheath that surrounds the nerve cell. So here you can see a normal nerve cell, so that's the nerve cell, and that would be the myelin sheath surrounding it. This would be in a person with MS. So you can see that the nerve cell is exposed, and when the nerve cell is exposed, it's hard for the signal to be transferred from the brain to whatever nerve cell that correlates to. So you can't really say like specific symptoms for MS because it depends on whatever nerve cell is damaged. That's the signal that's going to kind of be disrupted. And then there are two types of MS that they're going to talk about in this paper. The first one is secondary progressive MS, which means that there is a gradual increase in the severity of the disease, but it kind of goes up and down as it goes, while as primary progressive is just a steady increase in the disease. So you just keep getting worse until basically you just die. You all are probably wondering why I chose this really complicated article to present, and that's because my mom was diagnosed with MS 23 years ago. Her doctors actually wrote this paper, and they run the largest MS research center in the world, which is in New York City. In her specific case with like her symptoms and stuff, just as an example, the nerve cells that are damaged in her brain correlate to her left leg. So like she has trouble lifting up or walking with her left leg. She also has secondary progressive, which is like the up and down one. So some days you would never even know she's sick. Some of my friends never even knew she was sick. And some days she's in bed all day or has to walk around with a cane. So it really just depends. A lot of people in their presentations like to focus on the science and the data and all that stuff behind their article, but I kind of want to focus on the person behind my article and why I chose this article. I have lived my whole life fighting and going through this disease with my mom, so the fact that these doctors are possibly going to be able to come up with a way for other people to not have to live this life of disease is just really cool, I think. So the terms you need to know, the first one is CSF, which just stands for cerebrospinal fluid. So in all the patients that they looked at, they did a spinal tap, which is where you take like a really big needle and you stick it in their spine to get spinal fluid out. And then oligodendrocytes you can see them right here, and they support the axons and help produce the myelin sheath. So not only is myelin sheath important to protecting the nerve cells, but so are the oligodendrocytes. So in MS patients, you need not only nerve cells, but you also need oligodendrocytes if you're going to help this. Okay. Okay, so in this study, they took 54 patients. The first 18 were controls, meaning they did not have the disease. This next 18 had secondary progressive, which again is the up and down one. And then the last 18 had primary progressive, which is just a steady increase. You can see the median age and the gender ratio here. And then EDSS kind of represents the severity of the disease. So if you have a 0, that would be like us, or most of us were at like a 0, no symptoms, no disease, no nothing. And a 10 would basically be dead, so like a 9.9 would be like very, very bad. So you can see the different medians here. It's not the mean, it's the median also. So in this study, they grew stem cells in their lab, and they took spinal fluid from each patient, and they treated these stem cells with growth factors, and then put the stem cells into the spinal fluid. So when they put the spinal fluid back into the patient, their hope was that these stem cells would be able to go to the brain and target the areas that were damaged and kind of replenish the damage that had been done. Everyone good? Sorry. Okay, so first they want to see if they are able to repair the already damaged nerve cells and oligodendrocytes in the brain. So as you can see, there's like stars above everyone except GFAP, and that's because GFAP is the only gene that's not involved in neuronal development. So as the one all the way to the left is a control, so patients without MS, and then the other two are with MS. So you can see that after the spinal fluid treatment, this shows gene expression. So if the genes are related to neuronal development, if there are more genes, that means there is more development. So as you can see, there's a lot more genes, which is good because that means that the nerve cells that were not working are now working. And then this is a Western blot, which kind of shows pretty much the same thing, just in a different way. So you can see the first two columns are the patients with MS, and then the last two columns are just controls. And then they picked 4 different genes and tested them. And you can see the bands on the MS patients are a lot greater than the controls. Okay, so then they wanted to see if the new stem cells that they put in, what they would kind of turn into. Because a stem cell has to turn into something, but if you don't treat it with anything, they'll all clump together and form a tumor. So they treated it with growth factors, and then they put it back into each particular patient's spinal fluid. So here it kind of shows you what the stem cells turned into. So you can see in like a regular person, they would just equally turn into astrocytes, neurons, and oligodendrocytes. Astrocytes are just different cells in the brain that aren't neurons or oligodendrocytes. So if this is the part that's damaged, that's what you would want the stem cells to turn into. And you can see that these levels were higher than this, which is good because that means that they were able to replace the damaged cells in the brain. Okay, so in this article, they were able to use the spinal fluid treatment, and they were able to repair the nerve cells that were damaged because of MS. And then they were also able to target the stem cells to go to the specifically damaged areas in the brain to create new nerve cells so that it makes up for the damaged ones. In the article, the doctors say that this could possibly work with other diseases like MS. So that would maybe be the next step to try it with another disease. But also the cool thing about this is that there's lots of social and law issues with bone marrow transplants and having to get something from someone else's body and kind of put it into your body. And with this treatment, there's no rejection because the spinal fluid that they're putting back into your own body with these stem cells is your own spinal fluid. So you're not exposing your body to some unknown thing that they have to get used to. Also, something kind of on a side note that's really cool is that my mom's doctors got this approved in August to actually start doing as a treatment. So right now, 20 of their patients are undergoing this. So they picked 20 different patients that they thought would be best fit for this, and hopefully their symptoms would be reversed.
Can you go back to the graphs that you had? Yeah. So the CSF, the cerebral spinal fluid of an MS patient differentiates cells differently than the cerebral spinal fluid of a regular patient.
Correct.
So
somehow the disease is getting cells to yay. Somehow the disease is getting cells to differentiate. It's forcing the cells to differentiate into different cells.
Right. Into cells that were damaged that they need more of.
Hi, Gia.
I'm good. Did you hear my answer?
What's that?
Did you hear my answer? Yes.
Go back one more. So what?
Be nice.
So the So all of those, the bars that are represented on this graph, these
Yeah.
are genes responsible for specifically neuronal development
Correct.
or oligodendrocyte ganglions?
Just, it's a neuronal
neuronal
development. Yeah.
Why astrocytes?
No, astrocytes, like, were not important. Like, they didn't want it to turn into astrocytes. So here, in MS, what would be damaged would be the neurons and the oligodendrocytes. So that's what they would want more of. Because if you have more oligodendrocytes, you can make more myelin sheath, so that makes up for the damaged ones. So we did not want this level to be higher than these levels.
I don't know if I missed it, but what are the stem cells turn into when they treated them?
Their goal was to turn into neurons. This is what's showing what they turned into.
Oh, that's what they turned into.
Yeah. We wanted them to turn into these. Yeah.
So, what is an astrocyte?
Astrocyte's just another cell in the brain that's not. I don't know exactly what it is. Did you know?
Claire, can I help you?
Yeah, sure.
An astrocyte is one of the nutrient supporting tissues of the lung.
Okay.
It's very numerous in terms of the people that enter and place, and they don't dress in all tissue.
So it's not something that's damaged in MS, which is why they didn't need more of them. Does that make sense? Yeah.
How do they know that the cells that they're putting back into the patients aren't going to become like the damaged cells?
Well, if they if the cells are damaged and then they keep putting more in, and then you're gonna have to get the treatment every so often. So you're gonna
just
have to keep
constant.
replenishing
Okay.
the damaged cells. Yeah. It's not like stopping it; it's just replenishing. Yeah.
Do you know if your mom's doctors, if they chose 20 patients with PPMS? Because
Yeah, it doesn't matter because in the study there was no significant difference between SPMS and PPMS, so they could just choose either. It didn't matter. They have both. Yes.
From the graph, at least, it looks like there was quite a bit more.
Oligodendrocytes.
Yes, and neuron growth in PPMS patients.
Yeah. It was there was a lot more, but they said that it wasn't significant. It didn't mean anything different. It's not like then the PPMS patients are going to respond. They said it wasn't a significant enough difference to matter. You can still, both of them are still a lot greater than the control.
I was out for a chunk in the beginning, but where did the stem cells come from?
So they grew the stem cells in their lab.
Okay.
And then they put it they treat it with growth factors, and then they put it into the spinal fluid of the patients.
Were they embryonic or did they derive them from the patients?
From the patient.
What?
Spinal.
Spinal.
Okay. Someone else have an input?
So then, based on these results, would you expect PPMS patients to respond more effectively than SPMS patients?
They said it wasn't significant enough that you would say that. Yes.
are there any potential drawbacks from treatment?
It's not a cure. They still don't know exactly what causes MS, but it is a possible way to replenish. So, it's not the best treatment in the world because it's not going to take away your MS forever, but it's their hope that for an amount of time they can take away your symptoms and the damage that's done in your brain. Yeah.
So the stem cells you put back in, will those eventually become damaged?
Yeah.
And then you have to
And then you have to
replenish it
replenish again.
Okay.
Yes.
How long does the treatment take?
I'm not sure. I know that they're doing it right now, so we looked it up online. Yes.
How often do they have to go through the procedure again? How often do they have to replenish?
I don't know. Because in this article they only did it once. And so now that they're actually doing it on patients, I think they're kind of going to figure it out, but they didn't say they're not. Yeah.
Other than the way the symptoms kind of show themselves, do they know what the biological difference is between PPMS and SPMS patients?
I'm not sure. I'm not sure like why some patients go like up and down and why some, yeah. I'm not really sure. It might be the different nerve cells that are affected by it. Yeah.
Do you know if the stem, like the destruction of the stem cells is slowed down, like as the treatment is repeated?
I don't, because in this one they didn't like repeat it multiple times, they only did it once, so I guess that's maybe something they could do in the future. Yes.
How does the spinal fluid affect the stem cells?
So they took the spinal fluid from the patients, and then they put the stem cells into that spinal fluid, and then they put the spinal fluid back into the patient. So it's kind of a way to like transfer.
That's actually a really good question. A lot of the keys to differentiation of a cell from a stem cell into anything else cell is in the kind of fluid surrounding it. That was a really big experiment. Okay. So just to remind you guys, Project 80 is an attempt to use science to change things around you. So there's a lot of things that are not right in this world, and there are not a lot of things that are not right in this school. People see stress and sleep issues, they see bullying, they see intolerance of homosexuality, they see a lot of things. And the goal of Project 80 is to use data like what Claire presented to, I guess, change people's mind using some information. You can take on anything that you find important in the school. If you think there's something wrong here, and you think that educating people about it would help to change that thing, this is your chance to get involved. And we won't do it, we'll do it, you know, I don't know how to say this without swearing. With a great deal of effort. Enthusiastically even. And if you guys are itching for a chance to get your hands dirty in the lab, Walksman is a good place for you to go. You'll get to do a lot of research. It's guided, so you can walk in with absolutely no experience, and there are 10 spots available. So talk to Weinkoff, talk to Strachan or Berdeska about about Walksman, and talk to Gabby and Dana about Project 80. There are many spots available, so here's your chance. Have a great day, guys. Thank you.